Very good morning, class. In this video, I will discuss some numerical problem from the chapter Capacitance. There are numerical problem based on the capacitance, the parallel plate capacitor, and the combination of the capacitors and the energy stored in the capacitor. Okay, so let's start with the first numerical. On your screen, you can see the first numerical, what says. A capacitor, when charged to 1000 volt, takes 2 microcoulomb of charge. Find the capacity of the capacitor. So we have in the first numerical, so in this case voltage is 1000 volt and the charge is 2 microcoulomb. We have to find the capacity of the capacitor. So we know that simple. C is nothing but Q upon V. So Q is nothing but 2 microcoulomb, 2 into 10 to the power minus 6, and V is 1000. That means this will be 10 to the power 3. When it goes up, it will become 10 to the power minus 3. So C will be 2 into 10 to the power minus 9 farad, or simply 2 nanofarad. So this is quite easy numerical, just based on the formula. Let's see the another numerical. Let's see question number 4. What it says. What distance d between two parallel plates, each of area this of an air capacitor to be kept so that its capacitance is same as of conducting sphere of radius a equals to 0.5 meter, right? So in this question, the data we have is the distance between the plate is d, right? So distance is d, area of the plates A is given, A equals to 0.0314 meter square, and that's it. And the sphere conductor radius is 0.5 meter square. Now understand this question. It says suppose we have two capacitor. First we have a spherical conductor of radius A, and next we have a parallel plate capacitor having the area and the distance d. Let's say the capacitance, here the capacitance is C1 and here the capacitance is C2. It says both the capacitance are equal, right? So that what we have to find here, we have to find the d, the distance, right? So what will be the capacitance of PPC? Let's say this is, okay, what will be C1? C1 will be 4 pi epsilon naught A, and what will be C2? C2 will be epsilon naught A upon d. This was the formula. Now according to question, C1 and C2 both are equal, right? So according to question, C1 is equals to C2. Apply the equation. So 4 pi epsilon naught A is equals to epsilon naught A upon d, right? So this epsilon has been cancelled out. We can find the value of d from here. So what will be d then? So d will be A upon this. So A upon 4 pi into A. 4 pi into A, right? What is A we have is this. It is 0.0314 upon 4 into pi. Pi will be 3.14 into A is 0.5, right? So after calculating, we'll get 5 millimeter, right? Let's see the next numerical. So let's see the question number 9th. What is saying? A potential difference between the plates of parallel plate capacitor is 200 volt. Okay, so we have V is 200 volt. All right, next, the area of each plate is 100 centimeter square. Okay, so overlapped area will be same, that will be 100 centimeter square, or we can write it as 100 into 10 to the power minus 4 meter square, right? Why? Obviously in 1 centimeter 10 to the power minus 2 meters there, so in centimeter square 10 to the power minus 4. Okay, what next part? The distance between them is 1 mm, so d is 1 mm, millimeter, it means 10 to the power 3 meter. Okay, if the medium between them is air, so initially there is air, that means K will be 1. Okay, then calculate the charge taken by the capacitor. So let's solve this part first. Okay, then I will move to the next part. So first, in the first case, medium is air, so if medium is air, that means K will be 1, right? For because for the dielectric constant for the vacuum or for air is 1. So calculate the charge, right? We have to find the charge from here. Okay, so to find the charge, first we have to calculate the value of capacitance, right? So C equals to epsilon naught A upon D. What is the value of epsilon naught? It is 8.85 into 10 to the power minus 12 into A is this. So this can be written as 10 to the power minus 2, 10 to the power minus 2 divided by D. D is 1 mm, that is 10 to the power minus 3. So this will be the value of C. How much? 10 to the power minus 14, it will go up, plus 3, so minus 11, that will be 8.85 into 10 to the power minus 11 farad. But we have to find the charge Q, so Q will be C into V, right? So C is nothing but 8.85, so it is 8.85 into 10 to the power minus 11 into voltage is 200. So after solving it, 1.76 into 10 to the power minus 8 coulomb. So this is the first part. Now what is the next portion of this question? Let's see. It says, if the medium of dielectric constant 2.5 between the plates, then what will be potential difference for the same charge? Now if you know that if this parallel plate capacitor has been filled with dielectric constant K, right, then the potential V dash will be now V by K. So V dash will be 200 upon the value of K is 2.5. So when you solve this, you will get 80 volt. That means the potential has been reduced. So we can, what does it mean? That means we can give more charge to this capacitor and hence we can increase the capacity of this capacitor, right? Let's see the next numerical. Let's see the question number 12. It says, a parallel plate air capacitor has plate area 6 into 10 to the power minus 3 meters square. Okay, so question number 12, the area is how much? 6 into 10 to the power minus 3. 6 into 10 to the power minus 3 meters square. Okay, now, and plate separation is 3 mm, that means D. So we have D is 3 mm, it means 3 into 10 to the power minus 3 meters. Fine. A PD of 100 volt is established between its plates by a battery, right? So initial voltage, let's say I'm taking it V0, right? It is 100 volt, right? Now after disconnecting the battery, the space between the plate is filled by 3 mm thick mica sheet of dielectric constant K. Now obviously the distance D is 3 mm, and it says we have filled this, we have insert a mica sheet of 3 mm. It means we have filled the complete space between the plates. So what is the value of K? It is 6, right? Find the new PD. The first we have, what you have to find? The new PD, let's say that will be V dash. The final capacitance. Okay. So let's say here we take the capacitance C0, and here we will take the capacitance as C dash. Okay. And the final charge on the capacitor. And third, final charge on the capacitor. Okay, so let's solve this question. First, find out the C0, that means the capacitance of this capacitor while there is air between them. That means there is no dielectric medium between the plates. So C0 will be epsilon naught A upon D, right? So that will be epsilon naught is 8.85 into 10 to the power minus 12. Area is this 6 into 10 to the power minus 3, and D is 3 mm, 3 into 10 to the power minus 3, right? So this will cancel out, this will be twice. So C0 will be twice of 8.85 into 10 to the power minus 12 farad. I am not calculating this part. Okay. Now, first V dash. What will V dash? We know that V dash voltage will become 1 upon K times when dielectric inserted between the plates. So it will be V naught by K, nothing but 100 by 6, and this is the answer, this much volt. Second part, C dash. What is the final capacitance, right? C dash. So C dash will be K epsilon naught A by D, right? K epsilon naught A by D. See here, we have already calculated this value, right? This can be written as how? K into C0. This is the value of C0. So K value is 6 into 2 into 8.85 into 10 to the power minus 12, right? So C dash 106.2 into 10 to the power minus 12 farad. Now we can find the value of charge Q, C dash into V dash, and that will be also equal to C into V because charge will not change. Okay, so it will be C dash is this 106.2 into 10 to the power minus 12 into 100 by 6. So you can calculate what will be the answer. So that's how we can solve this numerical. Let's solve one last numerical from today's video. Question number 13. Okay, a parallel plate capacitor has a plate area of 90 centimeters square and separation 2.5. So A is, what is A is 90 centimeters square, and the plate separation is 2.5 into 10 to the power minus 3 meter. Find the stored electrostatic energy when it is charged to 400 volt. So this is the A part of this question. So we have to, if V is what, 400 volt, find U, right? And what is the B part? The energy stored in the electrostatic field between the capacitor, obtain energy density. Okay, that means you have to find the value of small u also. So in the B part we have to calculate small u. Let's solve it first. Okay, A, U is half CV square. We have V, so we have to find the value of first C also. So C will be epsilon naught A upon D, right? So what will be the value of epsilon? It is 8.85 into 10 to the power minus 12 into A is 90 centimeter square. So 90 into 10 to the power minus 4 upon D is 2.5 into 10 to the power minus 3. Okay, so when you solve it, C will be equals, so when you calculate this, you will get 31.86 into 10 to the power minus 12 farad, right? Now we have to calculate the value of U. What is U? U is half CV square, right? So half into C is this, it is 31.86 into 10 to the power minus 12, and V square, V is 400, so 400 square. So when you solve it, I am directly writing the answer, and the answer will be 2.55 into 10 to the power minus 6 joule, right? So this will be the answer. Now in the next part, in the B part, we have to calculate the value of U, which is nothing but U upon V, right? So U is this, it is 2.55 into 10 to the power, okay, U, what will be? V will be A into D, right? So it will be U upon A into D, right? So U is, we have 2.55, it is 2.55 into 10 to the power minus 6 upon the value of area. Area is 90 centimeter square, that means 90 into 10 to the power minus 4 upon D is 2.5, 10 to the power minus 3, 2.5 into 10 to the power minus 3. So you will get U equals to 0.113 joule per meter cube. That will be the value of energy density. So in the next video I'll make a video for some more numericals. Till then, thank you so much.